So let me share screen with you. Sharing yet? So for this,
Yes, I can see it.
yes, awesome. So before we go further, I just want to share with you some of the resources that I have prepared during the last weeks. So let me show you just a moment. Okay, so this post should have been public now. Let me double check to see if I can see it as a public. Okay, it should be, yes. So I created a checklist that contain all of the informations that we had been go through for a little bit. You need to move a little bit, like you need to drag a little bit here to see like the important. So whether it's a high or low or medium, you know, so pay attention to anything that have the high word here, so that you know like which one you should concentrate for the exam. And as we go on, we will add more information in this list. And alternative, I might just put this Excel sheet on the GitHub, because basically I just type it out and it doesn't look good on WordPress, you know. So maybe after the course, I'll just upload this whole thing on GitHub. But for now, it's a little bit nuisance to do that, because every time when I update the term, I have to revise it. So for now, let's use this. And at the end of the course, then I'll upload the whole thing up. So basically, for this, please pay attention to any term that I label high here. So like, and a lot of these things we have going to go over in the next sessions. So you know, things like storage. Well, we didn't go through storage access key, but like consistency level. So we talk a little bit about like consistency level. You remember about the theorem, and like why is it strong and why is eventual, right, in the theorem that we learned in the past session on the data engineer fundamental knowledge, and partition, you know, and different API and distributed tables and things like that. So I feel like there's a lot of concepts that we need to learn about NoSQL database. So, and a lot of times like I was forgetting it as well. So that's why I created this document. So anytime when you are unsure about something, please double check on this document. And if you see it's not there yet, then let me know. Then I'll routinely update this also. So for the past sessions, I think I have put everything in here. Yes. So like data masking, replicate tables, you know, data skew, hash key, distributed columns, distributed tables. So all are here already. So you can double check on it. So the second thing that I have done is just a moment. Let me open my document. Okay. So this is the exam review that I have taken from Siba, and also the course on Udemy. Remember, he was recommend us some course on Udemy, right? So in here, I found something that very interesting, is that the author, he also note out on things like, you know, what he think about the exam, and what we need to highlight on the material. So you know, he write my note on the section. So he basically divide the sections into topics like data warehouse, you know, Azure, data lake, synapse, things like that. And each session he has the my note on the tables, on the topics. So this also will help you to study for the exam. So I post this on GitHub. So I'll show you where to look for it. I have read it today, and it's very, very useful. So you can also take a look at it. So you can see here. You have to download it, I think. So those are the two those are the two materials that we have supplement for the next for the last week of the last week. Oh, hey Rahul, you guys got it all right? You guys got the materials all right? Okay, so just summarize again the two materials that we have is that we have the checklist on like different terms in Azure, and as we go on we will put more information on this so that we can use it as a study guide once when we forget about what it means in here, because there's a lot of vocabulary. And number two is please go ahead and read the exam review, and because it highlight on areas that you need to study to concentrate. For example, like Cosmo DB, you need to really look at like different API and when to use it, and also like hash table and different partitioning options. So please go ahead and read this. And also, if you see like my course that I didn't highlight some of these things, and let me know also, because I read through this and I think this is a very good and detailed note, and it's also would be very useful as a study guide. So let's start with this. Okay, so let's go back a little bit on the API, because I think we have a lab of 1 week, so so we might have forget this. So let me start sharing in the other computer. Just a moment. Hmm. That's, oh wait, I need to allow sharing. Okay. So Rahul, is it your first time in this course, or have you joined other sessions?
Yeah, hi Jen. This is the first session.
Oh, okay. Then you missed a little bit of the information of the course. So let me just quickly share with you back on the resource, and we can start this. So let me show you. Okay, so basically all the materials, I public it on on my GitHub. So slides, we have two slides: the foundation knowledge, which is the foundation knowledge of data engineers, and it's the core fundamental knowledge, and you use it and you can apply it to any clouds. And this is the session that we are talking about, which is like we just really study on Azure services, so a lot on cloud, a lot on particular of Azure options that are available. And the records for the past session, you can find it on this YouTube channel link. And I also made a blog post on the DP200 exam, so you can also click on here to find out information about it. So okay, so let me start sharing on.
Sure. Sure.
So oh, are you seeing my, okay, yeah, you're seeing my screen. Okay, let me stop share. So in this session, we will talk a little bit about different API services on Azure Cosmo DB. Hang on, let me see. So as the last time we mentioned, Cosmo DB is a NoSQL options for Azure, and the previous name is Document DB, right? So just a highlight, Rahul. So these are all of the options of storage that are available on Azure. So these are storage only, and we will have another session that extend on the data warehouse and relational data warehouse and non-relational data warehouse, and a lot of concepts like partitioning, distribute tables, distribute columns, and stuff like that on Azure. It will be a following session. So this session on storage, this part on storing data on Azure is just overview of what is available first, and then we will go to relational and non-relational data. And after that, we will talk about like different, like how to batch streaming, how to batch processing, and how to stream processing on the Azure. So let's review on the 5 different API of Cosmo DB that we learned last session. So we have the core, or like the SQL, MongoDB, Cassandra, Azure table and Gremlin. So last time I think you guys have been a little bit confused about when to use what API. So I dig a little bit further, and I see this information, and I think it will help a lot. So remember back when we first start in the class, I was talking about NoSQL, right? And there's 4 different type of SQL, NoSQL database, which is document, key value, graph, and columnar. So uh, aligning with these four database data options in NoSQL, we have SQL API, which is this. So it's more like to be able to query JSON format of data, and this is the option for SQL API, or also called Core API. And for MongoDB API that is available in Cosmo DB, we use Bison, which is for document. And remember, Cosmo DB, you can have 5 options of API: Core, MongoDB, Cassandra, Azure Table, and Gremlin. And when you have the key value type of database, then you need to use Table API. And when you have graph, then we have the Gremlin API. And when we have white columnar, and we use Cassandra API. So in here, it will help you to choose the API depends on the scenarios. So when the new project, you start the project from the scratch, so it's recommend you to use a core or SQL API. This SQL is not actually a SQL that you can see in relational database, but it's like SQL-like, it's still query on JSON data format. So if you already have the existing applications, existing database, as you see in the last quiz, that use MongoDB, Cassandra, Azure, Gremlin, then don't take time to transfer it to another type of API. You use, if you have like a MongoDB application, then you also need to use MongoDB API so that it can integrate faster. So also the number 2 things is aware of what you already have in the system already. And if your data is graph type, so this is why analyzing of relationship between data, then you need to use Gremlin, as you see in here. Okay, and all other case, then you need to use core SQL like. So to go back a little.
Jane, one question.
Yes.
Yeah, one question. Okay, so this relationship between data, right, for graph like data. Okay, so this is also available in, let's say, Cassandra. Okay, so if somebody already has application in Cassandra using this graph database, okay, so in that case also should one go with this Gremlin API
No,
in Cosmos, or
no, Cassandra is a white columnar. So number 1, you still use Cassandra API. And if your application exists in Cassandra already, then you should also use Cassandra for that.
okay? Mm-hmm.
So let me go back to this quiz so that let's do the quiz again so that we can be sure that we understand the different type of API. Okay, so this is the module from Azure from DB200. So if you type in DB200, and below it will be a study path from Azure, and you can check on for your knowledge in each of the module. So let's go ahead and do that and do some quiz on here. It's a little bit confused, Rahul. So it's a bit confused if you just look at this page to learn. So I would recommend you to go back to the last session. I also go into details of each step in this, and you can find the record on the YouTube channel on this. So go watch it first, and then reread the documents in here, and then if you would like, we can you can redo the knowledge check in this session. Okay, so in here, I think we have 3 questions. So let's go through with it together. So the first one, the e-commerce application. Here, let's have 2 minutes to check on what option we should choose for this. So let's talk on the 923 on the, what do you guys think of this option? Okay, you guys know an
So,
answer for this one's cost?
so there is no need to ask for, like, there is no existing application, right? It has to be a new. So yeah,
Yeah.
it either has to be core SQL or maybe
Mhm.
Gremlin if it needs to
Mhm.
have something.
Yeah, let's see. Let's see. Uh, how about this one? What you guys guess on this?
Gremlin,
Let's see. Number three.
Cassandra.
Okay, let's see if we got it. Yay, you got it. Congratulations. So let's
Thank
move on to the next session. To the next slide. Okay. So here are some exercise that we can also do. So in each of these exercise, there is a sandbox already, so you don't need to pay money for this. But then we only have another 30 minutes, so let's wait for this for the last the the last session in the last few minutes. So let's go through all the slides first, and if we still have time, then we will go back to this. So just overview. So in here we have some steps to create the Cosmo DB. So here the sandbox, and I haven't checked it out yet. I plan to check it out with you guys in the last session. But for the limit time today, let's see how much time we have left. And the step is basically first you create a Azure Cosmo account in your Azure subscription. And after that, you create database and container and items under it. And we will go through like what is containers, what is items, so that you guys can have the picture in mind of the structure of Cosmo DB. So here's the elements of Cosmo DB. You can see that we have the database accounts we created during our our first initial setup that you use the Azure subscription. So Cosmo account is the fundamental unit of global distribution and high availability, and it contains a unique DNS, and it manage you can access it by Azure portal, which is like user interface on web, or you use CLI or you use SDK. And once you create a Cosmo account, then you have a database. And also there's a concept of container, which is the fundamental unit for scalability, and it have the unlimited provision throughput. What is the provision throughput is basically that people can read and write, can read unlimited read in your database. So here are some of the items and the comparison. So each of the Azure Cosmos database and API support, there are different type of support for the container and different type of support for the items. So basically, you have to remember this. I double check on the mock exam again to see if there's a lot of frequent on this, but this is one of the highlight that I took out from the Udemy course, so that I put it here so you guys get aware of like which API, and
Jim,
there's
this,
a
this
different.
slide is not actually clearly visible. This
Oh,
pop-up is coming.
oh,
Pop-up is coming actually, so I
okay.
can't see the last line.
Let me try to see. Is it? Can you see better?
No, the last line is not visible actually.
Oh,
This
okay. Huh. Question. Okay, I think I need to put it still so that the pop-up disappear. Okay, it's disappear.
Yeah, yeah.
Okay, I will
Right.
move the arrows. So basically, if you have Azure Cosmos database. So for SQL API, you can query in database and Cassandra key space and so on. So please read on this, and it's basically you just have to remember there's no method on the not remember on the how to quickly to remember this. So that's it for the Cosmos DB, and I want to highlight again is that we will go through this again when we talk about no non-relational and relational database, and there will be a lot more concepts, which is like on a partition and distributing and data skill, things like that that I have introduced in the Azure Data Engineer. So Rahul, I also make a checklist of these terms because this checklist, so basically we contain all of the terms that we have been go through the last class and what we will study next in the next couple sessions. So like things like that we haven't studied yet, but things like Cosmos API, 5 different type of API, distributed table, hash key, distributed column. We already studied that in the past sessions. So please go through this to catch up with the class. And also there a good link is foundation knowledge that I also mentioned in here. And we won't touch on these terms until we reach to the NoSQL database. So you have a few more sessions. So good luck. Yes. And don't
Thank
worry
you.
so much. I'll talk about it all over again. So and let me know if you have more questions on that. So
Sure, sure.
let's go to the blob storage. And I want to highlight with you this. The blob storage is basically a container folders of files. So it doesn't matter like what file you put it there. It's just a very easy and effective way to dump files on the cloud. So like you have like a bunch of pictures or documents or anything that you want to back up. Blob storage is the way to go, and the way that blob storage structure on Azure is very similar to S3. So as I mentioned in the other class that I also use S3 and Blob Storage, and I can see that these services are back to back, and there's not much a difference between AWS and Azure in terms of like this type of storage offering. So anything that you learn in Azure, basically you can apply the same knowledge when you move to AWS and you use the S3 services. So let's talk a little bit about blob storage. It's designed for storing unstructured data, so like image, documents, and it's very simple design and easy to use. But then the thing is that it has the higher latency than the memory or local disk. So remember, when we go back here, we have like memory or local disk that used for virtual machine. So in here we have blob storage, and the thing that really limited of blob storage is that it doesn't have the index features. So it doesn't have the it doesn't have the file hierarchy features. So when you like want to indexing, when you want to query out files, it doesn't support that function. You can go away with that, but then there's a limitation on that. And in the upcoming slides, I'll talk about how we can use Azure Data Lake that built upon blob storage to address these limitations.
Right.
So
Jen, so in this case, like you were saying that since this is not a relational database, that's why we are not able to create index and all. But later on during data lake, like we have tools like Presto, right? That can basically read the data directly from Blob, or I don't know about Azure, but at least in AWS, like they have Athena and Presto, which can directly read data from S3.
yes. So it's similar to that. Like as I mentioned, it's exactly the same with EMR and data and Athena versus Azure HD Insight and data lake on blob storage. So the structure, I can see that like there isn't much difference on that. So yes, so if you use AWS S3, then this one is 90% similar. So you know, you also have like 3 tier, like hot, cool, achieve, and things like that. So yes,
Okay.
yes, and also like you store documents, you know, you access through browser, you know, you store like anything like audio, video files, you could stream it, you can like host website, and that's like really similar to S3. Yes, and you know,
Okay, static website, right?
yes, yeah, and things like, you know, it's scalable, it's cheap, it's way to store data. So and yeah, so I anything that apply to S3, I can see that is applied to blob storage as well. Yes, and
Okay.
as I mentioned, blob storage is usually not appropriate for structured data that need to be queried frequently, and so blob storage frequently combined with other database, or you can use data lake for that. And I just want to talk a little bit about hot, cool, and achieve feature. So hot tier, so it has the highest cost, but then it have the lowest high. So the hot tier is have the highest storage cost, but then lowest data access cost. So once you store things in blob storage, you know, and when you need to access it and when you need to like read and write it, there's certain fee that associate to it. So what it means is that it have what hot tier mean when I say it have the lowest data access cost. That means like compared to cool and achieve, hot storage when you read and write it, it have the lowest cost in read and write, but then it have the higher cost in storage. So if you want to store data for a long time and you don't need to access it often, then hot tier might not be appropriate to use comparing to cool and achieve. So remember this because it might be on the exam as well. So you can see here, this is the access and transaction, and this is the storage. So the higher, the lower the access. So that means like you want to access data frequent, then you use hot storage, and the higher the access, that means like the more difficult you gonna access the file. Like for example, if you use the cool mode, then it will take, there will be a longer latency. It will take you days to like receive data for like archive, for example, like it take even longer because the data is offline. But then the
But
storage,
Jen, so for cool, like how much time it take to get the data? Because for archive, like yeah, usually it takes few days, right? But for cool, it should not take days, right? It should be
well,
few hours at max.
it depends on the amount of data. So last time when I double check on the data, so I select like the speed and the cool mode, then it takes like 2 days for like 2 zettabyte, I think.
2 days, okay.
Yeah, for two
Then for
zettabyte.
archive, how many days? Archive, it will take weeks, huh?
Yeah, I think so. I need to double check again. But then from what I remember when because there's a calculation, you know, so basically you select like the tier that you want to store data and the speed of your
Mm-hmm.
internet. Like if you want to push the data up or get the data back, you know, then there's an option for like to calculate like how long it will take.
Okay.
Yes.
Mm-hmm.
So, but then the main thing is that archive is offline, so it will take much longer than cool and hot. And
Yeah.
yes, and you can define your data, your properties are here. So you see, like when you first put the data online, and you have 2 tier as default, as cool and hot. And if your data you doesn't use it often, and you just want some place to store it, and you store it as an archive, and to access, I think I write here. So sorry, I need to stop moving the mouse so that you can see it. So okay, to access your archive data back, you need to rehydrate back your storage tier to either hot or cool. So this process is called block rehydration. Basically, you bring it back to alive, and to the whole process will take several hours. And I want to also highlight, and you've been using AWS, so you also know this as well. So once you move to Kun, when you move to Archive, I believe, well, that's a fact, not the belief. They will charge you the fixed amount of 30 days. So even like when you have the store in like Kun or Archive, and if you want to move it out, they will still charge, and you only use that for 5 days, they will still charge 30 days for it. So that's it for the blob storage. Let me see what else I have in there. So okay, so so let's go to the blob storage use case. So some of the use case that like apps that need to transmit large amount of data using message system that only support a small message. You know, and the app can store data in blobs and send the blob URL in messages. Uh, and blob storage can be used to like file system to storing and share document and personal data, or like static website, and yeah, for like things like for many Azure components that are used behind blob behind the scene. And again, if your application doesn't need to be like query, doesn't need to be like have hierarchy file system, then please consider about blob storage. And I put it here because in the exam there are use cases where you have to analyze and select the proper services. So that is the purpose of this slide. So let's go to, you guys got it all right? Did you have enough time to read this slide yet?
Just going through it. Yeah, just a minute.
Okay, okay. I'll give you a few minutes. Yeah.
Yeah. Okay.
Yeah, so you know it's very similar to S3, right? Almost everything
Right.
is with AWS, then it's the same here.
Actually, does Azure have like multiple flavor of blob? Because I have seen some diagrams like where they have this generation 2, generation 3. I don't remember if it was for blob or it was for SQL, but yeah,
Oh,
they had multiple generations, right?
uh, no, it's for data lake. So data lake is have the S2. No, sorry. Data lake is has the Gen 2. So unless you have like specific purpose that you need to use the Gen 1, then you should use Gen 2 for data lake.
Okay. So blob is only one. There are no. Okay.
Yes. So now we talk about data lake, and please, because I forgot to put Gen 2 here. So when we talk about this, it means Gen 2 is not the Gen 1 data lake. Oh, hello, Stu. I just want to briefly talk about the resource again to make sure everyone know about the good resource, because I think this will help everyone a lot. So remember, in the Slack channel here, I already put the link of two resources. So sorry, I just want to make sure everyone got the access to the resource, because I want to help everyone get a good grade in the upcoming exam. So I don't have much time to talk about the whole thing, but basically there's a checklist where you can see all the terms that we have been going through, and please move your mouse to the last column, which is the important. So so you can have like high, low, medium. So remember, for all the high, please make sure you understand the concept and you get it, because it will be likely in the exam. Also, there's another really good resource on this, which is the check the exam review that I take from the Udacity Udemy course that was recommended by Zipbat, who is the guy who come to our last session to share about his experience with the exam and how, and he recommended this course, and I went through it and it's really good. So I was copying the note here so that everyone can also see what is the highlight areas, and you know how we should pay attention to the exams. And of course I'll use this as a guide to go through the course as well. So let's go back to this. So here is the, so now we learn about different limitation of Azure Blob Storage, like it use container-based object storage, and it have the flat hierarchy. So that's why it doesn't work with Hadoop. It's not optimized for query. Then that's why we have data lake which help address all of these issues. So I just want to go a little bit on what it means by hierarchy namespace and what it means by local and global redundancy. So that before moving on to the next session, the main thing you need to remember in this slide is that Hadoop can access directly to the data lake without need to move or transform data. And this is the biggest difference between the blob storage and data lake. Because blob storage, you cannot query, you have to do like things, ways to go around to be able to like data manipulation. And with the data lake, yes.
And so Jen, so this data breaks, right? So data breaks is integrated with the data lake, or it is also integrated with blob storage also?
Oh, good option. Good question. So Databricks is the different service on Azure. Is from the company data from the company of Databricks, and they provide the analytics platform. So you can call directly from blob storage. But then, how about if you have many files and you want to query, you want to select different files to like get the visualization? Then that when you need to use data lake. So it really depends on your use case. If you just have like one storage and you just want to query from directly from one folder in there, then there's no need to use the whole data lake. The data lake we need to use data lake is when we have multiple different files and we want to store it like in just like a lake where you want to dump everything in.
Mm. No, actually, why I was asking is because this blob storage is not supporting Hadoop, right? And Databricks, I think for storage it needs Hadoop, right? Because it is it because the
Uh,
data is distributed, so it has to be Hadoop, right?
no, it doesn't need to be. So Databricks is just basically an analytics platform, and you can
Yeah.
connect it to blob storage. But then to get the data for analyzing, but then it really depends on the amount and the complexity of your query that you want. So
No, but
again,
actually, Databricks is nothing but Spark only, right? So
yes,
Spark storage. Okay, so you're saying we can use normal storage for querying through Spark also. Okay. Mm-hmm.
yes. So if for example, if you just have like two files that the folders that you put it in and you don't mess the folder under anything, then you can access it to like just get the data out to do like data science, machine learning, building models. With that, it is fine. But how about if you have like 10 different users that want to use Databricks to build model together, and using blob storage wouldn't be efficiency. So that's why you need to use data lake where all the files can be dumped together and where like multiple people can use it together.
Okay.
Yes. So I'll talk in the next slide. You can see here. I'll talk in the next slide about the blob storage and hierarchy file system, and this is the architecture of Azure Data Lake. So let's go back. Oh, I forgot what I planned to talk about. Hang on, give me a moment. Oh yes. So basically, uh, the data structure and the support for Hadoop is the main difference between the data lake and the blob storage. And for hierarchical namespace, it will help you to have a folder structure that behave more like the traditional OS file system in terms of like moving renamings. And you will have the more control, access control in like or directory and subdirectory level. So you can see here, we talk about the local and global redundancy. So I just want to briefly go through this a little bit and we will go through it again. These terms are very, if you are new to cloud, it's easy to forget. So I want to make sure that I go through it as much as possible. So it will stick in mind and so you won't have issues in the exam. So redundancy. So there are two primary redundancy. So locally redundancy is where your data is copied 3 times within the single physical location. So for example, if you select Southeast Asia zone 1 as your area, as your zone, remember that your data is copied, synchronized 3 times in one single region. And you want to have zone redundancy is that your data will be copied across 3 availability zones in the primary region. So in here, it's a little bit different. So you not in Southeast Asia, you have Southeast Asia 1, 2, 3, right? Remember that your file will be copied in all of the 3 areas. It's just not located in Southeast Asia 1 anymore. So that is the redundancy of local and zone redundancy. And for global redundancy, that it will be copied into multiple different regions, and it's not only within the Southeast Asia anymore. So it depends on the use case. You can select the appropriate redundancy storage for this. And also, I want to bring to that the storage, the SLA level is depends on the region that you select. So the more region that you select, then the more the higher SLA it can commit it. So just a brief knowledge on what is redundancy. I will go through this again, but then pay attention for this, because if you're going to get the AZ900, there will be a lot of questions on like select the redundancy, disaster recovery and backup and things like that. So the next slide. The next slide is on the Azure Data Lake architecture. So you can see here is the fundamental of data lake is still built on the blob storage. You have things like object tiering, policy management at the back, and you also like high availability. HRDR is like high availability, and this disaster recovery, which what I mentioned. So all of this is still carry and support in blob storage, and it will be integrated in the Azure Data Lake. And in here, upon that, we have the hierarchy file system. So hierarchy file system, it basically is what like HDFS Hadoop file system, or like your file system in your Linux. It has hierarchical. So that is the name come from. And along with the file system, you have the security, you have the performance enhance, and you have the scale and cost effectiveness. So it all integrated in the file system. And to interact with the Azure Data Lake, you have 2 options of API. Number 1 is Blob API, and number 2 is ADSS Azure Data Lake API. So those are the 2 API that you need to remember to interact with Data Lake. Okay, so to summarize up, I just want you to remember about Azure Data Lake is Azure Blob is inexpensive, but it have very limited in the query options. So that's why we use Azure Data Lake when you usage become more complex, more varied, and more difficult to analyze. So we go to Data Lake. So it Hadoop compatible. It's a big data storage. It's scalable, high availability, and you need to access the data through Blob API and Data Lake File API. And the security is that we have a data encryption. We have support Active Directory. RBAC is Azure is an option on Azure Directory. So if you look in my blog post, and remember, I'll keep updating as we go on, you will see that the section on I mentioned about Azure role-based access control, which is RBAC in here. So it's in Azure Active Directory, the term in there. I will go through over it again, so don't worry. I just want to put it out so you have the concept and the term stick in mind. So for storage on Azure, we have data ingestion, and remember, in this is the structure of each of the options. I always read out what we use for ingest the data, what we use to secure the storage of the data, and how we access it. And remember this structure also in the exam. So how you access it, how you secure it, how you ingest or like extract the data. So data ingestion, basically you have data factory, Apache Scoop, which is a stack of Hadoop. Azure Storage Explorer AZ copy tool is where you copy the data from one place to another, and it can copy up to 2 TB, and it will break down into 20 small different files, and you can move the data from on-prem to cloud using this tool also, or like you use tools that are suitable for you. PowerShell, Visual Studio, I don't remember. Okay, so you can see more in this the learning module or like key features that I talk about. Data ingestion. You can see it here. Oh, 1 TB. Sorry. So it's split out into 200 gigabyte of 1 TB. So sorry, we have to correct it. Exact copy, the maximum is 1 TB, and we have queries language, and we have data security here. So before we go, oh, hang on. So we don't have the quiz for this session. So let's go back and do some hand-on with the Cosmo DB. Before we end the session, let's do some hand-on. Can you guys access the link that I give here? Or guys, can you access the link here, or you guys want to do it on yourself? We can do it as a class, also as an exercise list.
I think we can do it as an exercise only.
Oh, you guys want to do it on yourself?
Yeah.
Okay.
So
Okay. So on the last
this is
week,
step by step, right?
yes. So let me show you. So basically everything is already on the data box. You just need to sign in. So let me stop sharing here and share my personal computer. So let me show you on how to use it so that you can access on yourself. And this is why I really love Azure, learning Azure, because they provide you good tools. So for me here, I already logged in. So you can see that they have the sandbox, and you just need to activate the sandbox. Yeah. So basically you verify your account, you know. Uh, yes, and then oh gosh. Yeah. So basically you just oh, review the permission you allow to access. Basically, you said like don't abuse it, such as that and that, and it should be done. Yeah, so this option is no cost, so I would encourage everyone to go through with the sandbox. So to be able to have the hand-on and to understand the Cosmo DB better before we move in depth in like things like partition and data skew and things like that.
And Jen, this for data ingestion. Okay, so what is the fastest way to do this ingestion?
Oh, for data ingestion, it depends though. So what are you looking at? Because we have things like Azure Databricks, where you like can drag and drop your data, and also for Azure, if you use like distributed big data solution, there's a Scoop, there's Flink, there is OZ. So depends on your solution. Then you have multiple tools on to use.
Okay, but Scoop has a better performance. Like actually, I'm asking about like from the performance perspective. Okay, so like data factory will be fastest, or drag and drop. Actually, for an automatic way, like if we are doing any sort of, let's say, data migration from on premises to Azure. Okay,
Oh, it's
so what is the
the main thing would be your internet connection though, because You know, if
Yeah, that is one thing. Yeah, that is another thing. But other than internet connection, like from the tool perspective, is there any recommended tool for fast ingestion, or we can use any, like all of them have almost same
okay,
sort of
let
performance?
me show you a architecture. Okay, let's use last few minutes to talk about the this. So if you have a look at the blog post that I just made, I also mentioned about architecture, but then I want to highlight that this will not be in the exam. The exam removed this part already, so you don't need to consider about this. But then since I already write it, and so I put it here, so you can see in here about big data architecture on the Azure, and I'll show you here. So let's talk about ingestion. Hmm. Okay. Um, Firstly, when you need to do the ingestion, you need to see what type of your data, how is your data connection, because there will be no one tool that fitable to that. And let me talk about Kappa architecture. Okay, let me see if they have the example of Kappa. No. Okay. Oh no, wait, Lambda architecture. I don't know. Lambda. So use this as a guideline to answer your question would be really helpful in the structure your data properly. Let me see if I can find it. Okay, here for example, first you need ooh, okay, hang on. Let me get out the presentation that I prepared a few. Let me get out the presentation that I present a little bit ago on this. Mm, okay, sorry, my um, things all over the place. So that's why when I go back and take a look, it's a little bit messy. Okay, so this is the example of let me see if there is a better. Okay, this is the better example. So when you look at the ingestion, you need to look at your architecture overall. And in this picture, I'm showing you the architecture from Lambda, and you can go back and read the terms on like Lambda, why it called Lambda, and things like that. When you do ingestion, you need to see like what your type of ingestion, how is your data connection, what is the amount of your data, because there is no tool that like suit all. So in here, for example, when you have like IoT stream data and you have log event, then you need to use the stream ingestion. And these are the tools that are available to ingest your stream. And of course, if you apply it to batch ingestion, it won't be suitable for schedule ingestions. For example, you use Data Factory, and there are other tools that you can use. And tools are just a tools, you know, like knife is just a knife. You cannot compare Swiss knife with like the cooking knife. So it really depends on your purpose and how to use it. But for that, you should think about big data architecture as in the whether you want to structure your whole area, your whole your end-to-end data flow, like from the source to like visualization. What architecture you want to follow, whether it's Kafka or Lambda, and if you use Lambda, and what type of stream ingestion that you want to use, for example, Event Hub or Kafka. Because, for example, Kafka is Event Hub is suitable for like HTTP protocol, for example, like that. So in each of these, you have multiple questions that you need to ask yourself. And the batch scheduling is like when your data is not like streaming, when you don't have like data constantly, you just need to scheduling. Then you can like Azure Data Factory, you can use Flink, you can use Scoop, you can use sorry, Flink and Ozzy, sorry, forget about Scoop. Flink and Ozzy to like scheduling or like Azure Factory or like even like Airflow or Nifi that you install on the on-prem server to get the data to AWS to Azure. So it really depends on your structure and tools. It just tool everything.
Mhm. But Jin, this Uzi and this Airflow, these are the orchestrator, right? These are just basically they are to manage the workflow management. Okay. But for data movement, so they are showing in this diagram, they are showing the data factory, right? So is Azure recommending data factory to be used for batch ingestion? Actually, I'm concerned about batch ingestion only. So
Okay.
streaming is okay.
Okay, so basically Azure Data Factory is a stateless. So Azure Data Factory is more like drag and drop. There's no different. There's some difference between like a Nifi or Airflow or Uzi, but basically it's all do the one thing is that it's orchestrating the data flow.
Yeah, they are just workflow
Yes.
manager, right?
Yeah.
Airflow and
So
Uzi.
whether
Yeah.
you like drag and drop or whether you like to code the whole thing, then you use Airflow, or whether you like drag and drop but you want to integrate it with Hadoop, then you use Nifi, or you want like the solution that already well integrated on your Azure HD inside, and you can use Uzi. And like whether one tool is used better or not, it really depends on the amount of data you use, the experience of the people you use it for. Like if your team just like to drag and drop and be done with it, then maybe Data Factory on Nifi would be the suitable. Like you guys don't want any outside service to go into network, and you just want like to push the data on premise out as in this model, then maybe Airflow would be a, or like Nifi that you install on the on premise server would be a good option for you.
Mm. Okay.
Yes, but I would recommend first, before you go any further, please decide where the stream data ingestion or schedule, and where you want to put it after that, because it will affect your architecture.
Right, right. Yeah.
Yes. Okay. So I think that's it for the session today. Do you guys have any questions on this? So next week we will study the last module of this, which is the last module of the storage option, and then we will go in depth in each of the storage. So the last one would be the SQL database and data catalog, and after that we will go in depth into like relational, non-relational database. So please make sure the week after next week, please review on the terms, because when we talk about like distributing and partitioning and things like that, things could be a little bit more complex and more confusing. So please review the last sessions, and let me know if you have questions or concern. Okay, so thank you so much, guys, for participating, and see you later. Bye bye.